Assalamu alaikum everyone. Today we are going to conduct lecture number 26 of this course, Microprocessor and Assembly Language. And today we are going to talk about flag control instructions. So let's proceed to our topic. Okay, in this slide we are enlisting uh, all possible flag control instructions which are present in 8086 or 8088 microprocessor. So we're gonna see them one by one. Very first instruction that we are looking at is LAHF, which is load AH register from flags, and it serves for the purpose that it is going to load whatever the value of the flag, and it is going to copy that content from the flag into the AH register. And remember, AH register is higher byte of accumulator or AX register. This operation column indicates clearly what is going to happen, so one can see clearly that flags are going to copy inside that AH register. And since it is just a data transfer instruction, so it is not going to affect any flag, so that is why in flags affected column we don't see anything. It is clearly written, it is a none or no flags will get affected. Okay, the second instruction that we are going to see in this lecture is store AH into flags, or SAHF, and it is just opposite what we see in LAHF. In the first instruction we were loading flags into the AH register, and this will perform totally opposite action. It will be actually loading AH register into the flags. That is why it is also saying storing the value of AH into the flags. And furthermore, this operation sign is also indicated here. We see that AH is going to transfer inside the flag, but this time there will be number of flags which can get affect from this operation. Why? Because we are actually changing the flag status, so there will be effects on the flags. So sign flag, zero flag, auxiliary flag, parity flag, or the carry flag, they are going to change their effects. Okay, the third instruction that we are going to see in this lecture is CLC. It is very important and very simple instruction, but it's very useful because there are a number of times when we need to clear the carry. So if there is a carry and we don't want it to be present for the next coming execution, so we can clear it in advance by just using this instruction CLC. It's like clear a screen, as we are using in any high level language, clearing the screen. So here it will be actually, or CLS, what's the mnemonic of that command, clear screen, but here we are seeing it clear carry. So if we want to clear the carry, we need to just use this command. And of course operation is very simple. 0 will be transferred into the carry flag, so only carry flag is going to get effect from this specific command. Okay, next command, it is just opposite to CLC. What we are seeing, set carry, or STC, which is set carry flag. So if we want to set the carry flag deliberately, we have to use this instruction, or we have to use this command STC. So what is going to happen? One is going to transfer inside the carry flag, and of course it will be affecting only carry flag. These two commands, CLC and STC, these are very important command. Once we are going to deal with application programs, hopefully we will see the magic of this program. Okay, not only CLC and STC, that means we want to clear or we want to set the carry flags, but there are some conditions where we want to just change whatever the status of a carry flag. If it is equal to 0, we want to change it to 1. If it is equal to 1, we want to change it to 0. So in such scenario, CMC, which is complement carry flag, is used. So CMC is very alternatively used command. So if we want to perform STC and carry flag is 0, we can use CMC, and if we want to perform CLC and carry flag is set, so we can use CMC. So CMC is alternatively usable option for CLC and STC. So I believe it is also important command, and we're gonna see its effect. The operation is clearly written that CF, whatever the value of CF, it is going to get complemented. That is why it's complement sign we can see here. Furthermore, in simple words, one can say if it is 0 and we want to make it 1, we have to use CMC, and if it is 1 and we want to make it 0, then we have to use CMC. And again, it is again going to just affecting only carry flags, that is why CF is mentioned in this last column. Okay, what is our next command, which is CLI, and it is also interconnected with the next command, which is STI, and these two commands are just about interrupt flag, as we saw CLC and STC, which were actually clearing and setting up carry flag, and here CLI and STI is basically clearing up or setting up interrupt flag. We know that clear means 0 and 1 means set. So if you want to set a flag, that means we want to make that flag equal to 1, and if we want to clear the flag, that means we want to make that flag equals to 0. So CLI means clear interrupt flag. That means there is an interrupt flag. If you remember, there are 6 status flags and there are 3 control flags. So one of those control flags is basically interrupt flag, which is actually indicating is there any specific kind of interrupts are enabled or not, or they are masked or not. So we can actually mask or unmask those interrupts using this CLI or STI. It is clearly written whatever I have explained in this operation, that if we want to clear it, so that means 0 is going to transfer inside that interrupt flag, and if you want to set it up, then 1 is going to transfer in interrupt flag. And since these two instructions are just going to affect only interrupt flag, so that is why only IF flag is mentioned in last column. I hope these explanations of these instructions is much clear, and now we are going to see these examples in emulator. So let's proceed to emulator example. Okay, in this slide we are going to discuss about mapping which is performed between AH register and status flag register. We need to know about it before understanding of these instructions. So AH register is going to map with flag, status flag register, right, or status register, whatever you call it. Okay, and these bits are basically shown here. So let's say if you are going from status flag, okay, from status flag to AH register, right? This is our status flag. I mean, we are moving towards from SF to HF. So these mapping will be performed, and remember these bits, 0 bit, right? Let me use my pointer. 0 bit is going to map with carry flag, and then this first bit of AH register, it is always going to be 1 when values are coming from flag register, right? And then second bit of AH register is going to be whatever the value of PF or the parity flag. Third bit is going to be 0, right, or it will be simply don't care. Fourth bit will be the value of the AF. Fifth bit of AH will be simply 0 or don't care. Sixth bit of AH is going to be the content of the ZF or the 0 flag, and the seventh bit of AH register, it is going to be the content of sign flag. So that's how values are going to get copied from sign flag into the AH register, and this is the principle that we are going to use. Here we need to be very careful about this bit number 1, that it is going to be 1 always whenever we are copying the content, though it is not mapped with any of the flag or any of the status register, so it is going to get copy 1. So it will be always equal to 1 whenever we are loading values from status flag into the AH flag. Remember, this is not sign flag, this is status flag. So whatever the values which are going from status flag into AH register, it is going to follow this fashion of mapping, right? So let's proceed and follow this mapping in our slides. Okay, let's proceed to our example of LAHF. And remember, this command, what it does, it actually copies whatever the value which is shown in the flag, it is going to copy inside the edge, and mapping will be followed as I explained in the last slide. Using this, sign flag will get copy in 7th bit, SAHF flag is going to copy in 6th bit, auxiliary flag is going to copy in 4 number bit, and parity flag is going to copy into 2nd bit, and carry flag is going to copy in the 0th bit. And remember one thing which was different from every other bit, and it is about first bit, it will always be equals to what, equals to 1. So that is the logic that we are going to follow. So let's write some example. Let's say we gonna write move ax comma 1 2 3 4 hex. It is the normal example that I normally take in every lecture. And now we gonna add move some value in bx. Let's say we gonna take 0f 28256 hex. Okay, and now we gonna add them, add ax comma bx. So the result will come up in ax, and now we gonna do what, we will be actually saving the result into cx. So cx comma ax, and then we will load the value of status flag into AH register. So this is the program we're gonna follow. Let's see if there is any error or not by pressing the button emulate. So I'm gonna press button emulate. Okay, there is no error, I pressed it. The first instruction 1 2 3 4 is loaded successfully, nothing to explain here. Next instruction 0f256 is going to load, so f256, let's see, single step, yes, f256. Okay, I have opened here flag register for you so that you can see if there is any change. So far we don't see any change. Remember, we have to focus on these flags. Remember, this is the status flag in which we are interested, right? These three flags, these two flags which are interrupt flag or directional flag are not going to perform any action or any role in these commands, right? So now what we are going to do, we are going to add. Okay, result is added here 048A. Look, the carry flag is high, remaining bits which are of our interest are 0, so we know that only one bit is our interest and it is equal to 1. And now we are going to save this result, which is 048A into cx. So let's perform. Okay, the result is moved. Now whatever the value of status register, we want to move it into AH part, so we will be using this mapping. So 7th bit is going to be sign flag, which is 0. 6th bit is going to be what, 0 flag, which is 0. 5th bit is not mentioned, it is going to 0. 4th bit, it is auxiliary flag, it is also 0, so it is 0. 3rd number bit, that is basically not defined, so it is going to be 0. 2nd number bit, it's parity flag, it is also 0, so it is 0. And now we come to the very important flag, which is bit number 1. It is always going to be 1, so it is 1. And then carry flag, it is going to be 0 bit, and carry flag value is what, 1, so it is 1. So if we convert that thing into hexadecimal, that is going to be 03 hex. So if we run this command LAHF, the 03 hex will be loaded into AH register. So let's see if it is going to happen or not. Yes, I hope this point is clear. Okay, just to explain it further, we can take one more example.
Where is my pen?
Okay, now we're gonna take one more example. So let's say we change these values just to clarify if there was any kind of mapping calculation, the f2 and f2. Okay, I'm just changing the value of ax. Okay, if I can also vary it, let's say e6. So let's hope we will have certain. Okay, where is, okay, here I missed this 0 prefix. Okay, now everything is okay. Press simulate. Okay, everything fine. f234 is loaded, perfect. f2e6 is loaded, perfect. Value is added. Now we see sign flag, carry flag, these two bits are high. Okay, and furthermore we're gonna save this result in cx. Okay, and now we are performing this LAHF, and before it I want to do it myself in manually. So let's do it. And if you do it myself with my C, if you do it with me, you will be able to understand it. So sign flag is basically 1, so 7th bit is 1. 0 flag is 6, which is 0. Fifth number bit it is not defined, so it will be 0. Fourth number is auxiliary flag, which is 0. Third number is not defined, so it's 0. Second number is parity flag, it is going to be 0. And first number is what is basically equal to always 1, and carry flag is 1, so it is also 1. So if we convert it into hexadecimal, it is going to be 83 hex. So let's see if this value is going to load inside AH register or not. Yes, it is 83. So I hope this explanation is clear how this LAHF command works. Okay, in this slide we are going to discuss about SAHF, which is store whatever the value of AH into the flag register, and of course we will be following this mapping. So let's see if it is going to work or not. Move, let's say move AX, we have certain value 452623 hex, and we want to because whatever the value of AH we want to move it into status flag. So using this mapping, so we can just simply use what SAHF. What is the value of AH? Just for the knowledge purpose, AH is what 45 in this example. So if I am going to convert it into bits, it will be equal to what? It will be equal to 0100 and 0101. So that actually tells us carry flag. Okay, I'm just gonna write here carry flag is what 0 flag, which is 0 bit, which is 1. Okay, parity flag is also 1, right? And bit number 6 is what ZF, so it is also equal to 1. The rest of the bits will be same. So let's see if it is going to work or not. We press simulate single step, it is loaded. Okay, this is our flag before this command, and now I'm going to press it. So one can see carry flag is high as I expected, ZF is high as I told you, and parity flag is high as I told you. So in this manner you can actually transfer whatever the value in your AH into the status register. Okay, we take another example just to clarify it further. Let's take this time I'm just gonna use 8-bit. Okay, 59 hex. Okay, so I'm going to convert it into directly into binary 0101 1001. So according to that bit carry flag is high, and third number bit is not connected with any of the flags, so it is not concerned. Fourth number bit is auxiliary carry, it is high, and sixth number bit is ZF flag, ZF. So it is going, these flags will be equal to 1, and remaining flag will be simply 0. So let's emulate this program. We're gonna run it. 59 is loaded, and look, carry flag, ZF and AF, these are equal to 1, remaining are equals to 0. So I hope this point is clear to everyone, and this is how this SAHF or store AH register into flags works. Okay, in this slide I'm going to talk about 3 different commands: CLC, STC and CMC, and you know these all related with one flag, which is carry flag. Okay, and what I'm going to do, okay, I'm sorry, yes, I'm gonna see, and I'm gonna program just one any simple program. Let's say move AX 1 2 3 4 5 6, okay, sorry, hex, and then move PX is, let's say 0F262 hex, and I'm gonna add it AH comma BX. So let's see if carry is going to get effect or not. Okay, where is this? Is the mistake. Yes, so single step 1 2 3 4 is loaded, F265 is loaded successfully. Now I'm gonna do what? I'm gonna do addition, and you see this carry flag is high, and I want to just clear it by using what instruction? This instruction, CLC. So it will be cleared. What we can do, we can use STC just to make it once again high, and then we can complement it using CMC. So I'm just using this command just to make it further complement. So let's rerun this program using these three instructions. So let's emulate. 1234 is loaded, F265 is loaded successfully. So I'm gonna add these two things, which is 0499, and you see this carry flag is high, and in this carry flag we are interested. So far this command is executed. Now we are going to clear it. So carry flag is equal to 1, and once we are going to execute this command, this will become 0. Let's see if it is becoming 0 or not. Look, I executed it and it becomes 0. Now the next command was stc, so it will make it again high or set it. So look, it is again 1, and if we want to make it 0 again, so we can use alternatively what CMC, which is complement carry. So right now carry flag is 1, and if we use carry flag CMC, which means we are complementing it, so complement of 1 would be 0, so it will become into 0. So let's see if it is going to be 0 or not. Yes, it is going to be 0. So in this manner you can use these three different instructions: CLC, STC, CMC, clear carry, set carry, or complement carry according to need of the program. And there is an interesting question: where we gonna need these CLC, STC, and CMC commands? Whenever we are interested in carry to play with, to manipulate it, and there are a number of situations. We are going to see those situation in application programs. So hopefully our course proceeds and we reach that point where you're gonna use these instructions. So I hope this point is clear at this stage. Okay, that's it from this lecture. I hope today we covered status control instructions or flag control instructions like SAHF or LAHF, and we also learned about CMC, STC, or CLC. I skipped two instructions which are related with interrupt flag, which is the reason behind that skipping is basically because we didn't cover any interrupts in that course, in this course, up to this point. So I did not use those instructions, but once we reach to that point where we are going to play with interrupt service routine programs, so we will be dealing with these flag control registers as instructions as well. But for that moment, for this for up to the knowledge we have learned, these instructions are fine. So if you have any queries in these instructions, please note them down, and we are going to deal with these queries in coming online session. So that's it from this lecture. Thank you so much for listening.